All right, so let's get into this one. It says merge two binary trees. So I actually haven't worked with too many binary trees. I need to practice this, so this will be a good one for me. So it says given two binary trees, and imagine that when you put one of them to cover the other, some nodes of the two trees are overlapped while the others are not. You need to merge them into a new binary tree. The merge rule is that if two nodes overlap, sum the node values up as the new value of the merged node. Otherwise, the not null node will be used as the node of the tree. Okay, so I'm thinking so it's always, both trees are always going to have a zero node. Well, maybe not. Maybe they'll pass me. If one of the trees is null, I just return the other tree. So maybe we'll start off with that. So if t1 equals nil, then there's no t1 tree, so I just return the t2 tree. Return t2. If t2 is nil, then I just return t1 because there's no t2 tree. Okay, so that's some easy checking of the parameters right there. Okay, so now if it makes it past both of those, we know each tree is at least has the one node in it. So we can start at that first node. And okay, so I don't know a lot about binary trees, but I think there's like 3 ways to traverse them. You can go all the way down left and then like the left branch, and then go down all the left branches of the sub branches, and then go down the right branches, and then switch to the right branch and do the same thing. Or you can do it by like levels, so like go across to each level. So for example, I could go 1, 3, 5, and then 2, or I could go 1, 3, 2, 5. So there's a couple ways to traverse these trees. I'm not super familiar with like the actual implementation of that, but I think for me it would just be easiest if I just did some type of recursion where I take in the full tree the first time through, the full 2 trees, and then I just pass in the left tree, and then that would just pass in its left tree until I got to a node where if the left and right trees are nil, then I would want to return. So it seems like, will these conditions meet that case if I'm calling recursion? Will they, if t1 equals nil, return t2? So that's not checking the left or right nodes at all. Okay, I'm just gonna actually try it just an iteratively solution, because sometimes recursion I just get like a little bit lost. Okay, so let's try it. So I'm gonna start at Let's just do a while loop. So let's just do it with one. Let's just try to break it into one case. So where we have two nodes, just this one, and they don't have anything below them. So let's say if some node values up as a new value of the merge node, otherwise the not null node will be used as the node of the new tree. Okay, so answer tree node, this will be the first node, dot val equals t1.val plus t2.val. So this is the basic formula. So I sum up the current nodes, and that equals the answer trees node. And then I would need to traverse to the next level and sum those up. So maybe I go left. So then I say answer tree node dot left equals t1 dot left plus t2 dot left. Dot val. Oh, so I need to check. I need to check every time. If t1 dot left is not nil. If t1 dot left does not equal nil, then I can say var left val int left val equals t1 dot left dot val. Okay, and then I can say left val dot left dot val. And the same thing for the right. Oh, sorry. No. This is also left val 2. If t2 dot left, then left val 2 equals t2 dot left val, and then add left val 2. I know this won't work, but I'm just kind of doing it, like hard coding in what will happen, so I kind of start to understand it a little better, and then I'll wrap it up in a function that I can use recursion with, or put it in a for loop. Okay, so that would, at this point, my answer tree node would have a root node with a value of the two trees root nodes added together, and then it would have a left node of the two left nodes values added together. Okay, so now I just have to, that's what needs to happen. So there's a few components. There's got to be a check that the node that I'm trying to take its value of isn't nil, and then there's after that, those checks, all we do is just add them together. And this will be nice because this will just get defaulted. These will default to 0. So if it never goes in this if statement, we'll add whatever one wasn't nil to 0. So that's good. Oh man, so how am I gonna traverse this tree. I just don't know how to traverse binary trees very well. I just haven't really studied that. That'll be something good that I can study, but I'll give it a shot. So if I go to the left, let me get a little sticky note here and just kind of draw it out. So the first node of the first tree, first node of the second tree, second node of the first tree, second node of the second tree, third node of the first tree, third node of the second tree. Okay. Okay, so if I had this like that, start here, add these two, go left, add these two, and then go left again, and then add those two. So my issue is, if I'm traversing this tree, like let's say I go left, so I start here, and I go left, and that's fine, and then I just go left on this tree too, and I add them together. And then let's say I go left, so I go down here, and then this one is nil, so it'd just be 5, but then now I'm at the end. Now I'm at like a leaf of the tree. So how do I get back? How do I get back up to where I left off so I can go right? Because there's no like reverse direction. Maybe I need to leave like a breadcrumb? Oh man. Maybe I need to leave some sort of breadcrumb so I can get back up the tree, but then I'd have to leave a breadcrumb at every point, which I don't know if I could do. Like if I went down to 5 here and I left a breadcrumb, basically just a pointer back up to this node, then I could go back to that node. But then I'd also have had to have left a breadcrumb back up to this node. So when I, am done going in the right direction, I can come back up here and go right. So I'd have to leave like all these breadcrumbs that let me traverse back up the tree. So I'm gonna Google how to traverse a binary tree just because I don't know how. Binary tree traversal. Tree traversal. In order, pre-order, and post-order. Unlike linear data structures, array, linked list, queue stacks, which have only one logical way to traverse them, trees can be traversed in different ways. Following are the generally used ways for traversing trees. Okay, so these were the 3 ways: in order, pre-order, and post-order. So left, root, right. What does that mean? Left, root, right. Oh, so you go all the way 4, 2, 5, 1, 3. Okay, so you start all the way from the bottom left and you work your way back to the root and then go right and then back to the root and then go right. So you're going at the bottom left and you're going up, down, up, down. Okay. Pre-order, root, left, left, so root, down to the left, and back up to the right, back up to the right, or post order left, right root. 4, 5, 2, 3, 1. So you're starting at the bottom and just going across the rows. Oh, so those are depth first traversals. So that, okay. So that digs all the way down to the last first. Well, not first, but so this would be the last leaf node on the left first. It goes all the way down to the left leaf node, last leaf node. Okay. Breath first. I think I might want breath first, because it, yeah, that sounds good to me. So breath first. So that's where you're just going across these rows. So you go all the way across before you drop down a level. Please solve it on practice first before moving on to the solution. Use function to print a given level. There are basically two functions in this method. One is to print all nodes at a given level, print green level, and others to print level order traversal, order tree traversal. Tree height. Print given level. Print given. If tree is null, then return. Okay, so they are using recursion here. So you take in a tree. In my case, I'll take in 2 trees and a level. If tree is null, then return. If level is 1, then print tree data. Else if level greater than 1, then you do the recursion. New node. Level order traversal of the tree. Huh. This is a tough one. I think I just need to find, my problem, I know what to do. My problem is just, I'll leave that actually. My problem is just, I don't know how to traverse a binary tree. It's just confusing to me. The recursion is just hard to wrap my brain around. So I'm going to say recursion. Man, it gets me every time. Print level order. So they have a new function, print given level, which calls print given level. So func add level takes in 2 trees, 2 tree nodes. Okay. And then what does it have to return? Maybe it also has to take in the answer node. Answer node, tree node. So, and then does it return anything? I guess it's a pointer, so I can just change it. is where I can do this, check. No, so I'm just going to make it one function. Okay, so if t1 is ever nil, then man. Breadth first traversal for the tree. Okay, breadth first search is an algorithm for traversing or searching tree or graph data structures. It starts at the tree root, or some arbitrary node of a graph, sometimes referred to as a search key, and explores all of the neighbor nodes at the present depth prior to moving on to the nodes at the next depth level. Okay, it uses the opposite strategy as depth first search, which instead explores the node branch as far as possible before being forced to backtrack and expand other nodes. Breadth first search and its application in finding connected components of graphs were invented in 1945 by Konrad Zuse. Was the world's first programmable computer, the functional program controlled Turing complete C3. Oh, that's cool. Okay, in his rejected PhD thesis on the Plankalkul programming language, but this was not published until 1972, pseudocode. Input, a graph G and a starting vertex root of G. Goal state, the parent link trace, the shortest path back to root. Breadth first search takes in G, which is a graph, which is the tree, and a root, which is the starting point. Let Q be a Q, label root as discovered. Q.NQ root. While Q is not empty, equals DQ. If V is the goal, then return V for all edges. More details. This non-recursive implementation is similar to the non-recursive implementation of depth first search, but differs from it in two ways. It uses a queue, first in, first out, instead of a stack. And it checks whether a vertex has been discovered before unqueuing the vertex, rather than delaying this check until the vertex is dequeued from the queue. If G is a tree, the depth first search algorithm for general graphs replacing the stack of the iterative depth first search implementation. The following is an example of the breadth first tree obtained by running a breadth first search on German cities starting from Frankfurt. Here. 1, 2, 3, 4, 5. Level order traversal. On practice first before moving. Please solve it on practice first before moving on to the solution. The heck? You're given a tree and you need to do the level order traversal on this tree. Level order traversal is of a tree is breadth first traversal. Okay. Oops. First line of input contains the number of test cases t. For each test case, there will be only a single line of input, which is a string, representing the trees described below. I have to log in. It's annoying. A binary tree traversal using different methods. Pre-order, in order, post order. The above methods. Oh, it'll mark the current node as visited first. That's kind of like the breadcrumb type thing I was talking about. Well, if the left child exists, it will go to the left subtree and continue the same process. After visiting the left subtree, it will then move to its right subtree and continue the same process. Huh. So it is just using, if it's no return, if it's not, put it, pass in the left, pass in the right. Traverse tree. It takes in a tree. Return, otherwise print the value. Print line t.val, and then call traverse tree t.left, traverse tree t.right. Okay, so I'm just gonna see if this works. Traverse tree T1, traverse tree T2. I just want to see if this traversal of a tree actually works. So we got 1, 3. So we're doing the first one. So we have 1, 3, 2. So that's going to go left first. Okay, and it's going to come in here. It's going to go left again. It's going to keep going left. 1, 3, 5, 2. Okay, sweet. So that did it. 2, 1, 4, 3, 7. Okay, so it's working. So it's reversing the traversing the trees. So now I just need to have this traverse 2 trees at the same time. Traverse trees T2, T1, 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 T2. Okay. And then I just need to have an answer tree that I'm building up. Return T2. Traverse trees T1, T2, answer tree node. Okay. Okay, so now instead of printing, I need to add, oops, instead of printing, I just need to T2 dot left, T2 dot right, traverse trees. Okay. So if T1, so answer tree, oh man. So I need to kind of keep track of what level I'm on so I can insert into the answer tree. Not quite sure. So I'm thinking I also need to traverse my answer tree. So if it's the first time through, I just need to say, okay, if T1 answer tree node dot val equals T1 dot val plus T2 dot val. Okay, that's gonna have my first node, and then I should also pass in okay, so before I go down a level, okay, so before I go down a level, oh, so I should do this in here. Okay, so before I go down a level, I can set that equal to t1.val. Okay, if t1 okay, so let's see, if t1 equals val, okay, answer tree dot val equals t1 dot val plus t2 dot val. Okay, and then I need to pass in answer tree maybe I should just set it equal to empty. So answer tree dot left equals tree node. So just set it equal to an empty one. Answer tree dot right equals tree node, and then just pass that in, and then just pass that in. Okay. So then we drop down a level. If this is nil, return. It just comes back up. Okay, well, let's break these apart. So if t1 is nil, I just want to set answer tree dot val equals t2 dot val. If t2 okay, if they're both nil, just return. If just t1 or if just t2 equals nil, then I want to set answer tree dot val equal to t1 dot val. And if just t1 is nil, then I want to set answer tree dot val equal to t2 dot val. So this will take care of if one or the other is null or both. Otherwise, it will skip all these and it will just add the current level as t2.val plus t1.val, set the left and right to null, and then pass that in. Okay. And then at the end of the day, what if fmt.println answer tree node run code. Oh. Answer tree.val equals t2val. Answer tree.val undefined. Type pointer to LeetCode.tree node has no field or method val. Oh. Capitalize that. Oh, it's a pointer. Pointer. Okay. Invalid memory address or nil depointer reference. So one or the other of these is nil. Oh. I forgot returns here. Okay. Huh, invalid. think this is starting off as nil. So maybe I want to start it off as an empty tree node instead of that. Okay. So that should not be nil anymore. Oh, whoa. It kind of did it. Except for it's 0 instead of null. Huh. So I'm just missing one position where I'm not setting it equal to. So maybe here, instead of just returning, I have to set answer tree equal to nil. Huh. It's kind of doing it. It's doing it, but it's not. It should be null instead of 0. Why is it 0? So it goes in. If both of the nodes are nil, it's going to set the answer tree equal to nil. That's good. Okay, that seems correct. If 2's nil, then it's just going to add. It's just going to set answer tree's val to t1's val. That's good. If 1 is nil, it's just going to set it to t2. Otherwise, it's going to add them. And then it's going to set 0. Huh. Maybe I do want those to be nil. Maybe I have to initialize them. So maybe I set these to nil by default. Maybe I set these to nil by default. And then I set this to nil by default. And then that way, if I don't have to do this because it'll already be nil. So that way, okay. Answer tree equals pointer to a tree node. And answer tree dot. See if that does anything. If I just default answer tree to nil. Well, that didn't help. That did not work. Let's go back here. I think I was on the right track before I changed all this. Tree node. Okay, let's run that. Huh, so everything's good except for this 0 needs to be a null. I have a hack that might work. It's kind of terrible. No, that's stupid. I just need to set, I just need to find out why it's being set to 0 and just set it to nil. Set the entire tree node to nil. So I'm printing out 3, 4, 5, 5, 4, and then I'm printing out a 0 right here, 7, and I need to print out a nil. So this is because this gets added in, this gets added in. Neither of them have a left node on this guy, so that okay, so if t1 equals nil, return t2. If t2 equals nil, return t1. Traverse trees. If t1 equals nil, if the left, so at a certain point I should be passing in nil, nil, so it should be t1 equals nil and t2 equals nil. Then I want to say answer tree. I want to set that equal to nil. Okay, and then return. So those return. Man, it's still 0. Why is it printing out 0? So if, even after I tried a hacky way, I tried to say, at the end of the day, I'm just going to go through the answer tree once and take any node that's 0 and just set it to nil. I thought that would work, but that still didn't work. I'm setting a tree equal to nil. Oh man, maybe if I put it here, a tree equals nil. Man, I'm kind of doing a hacky. I'm kind of hacking it. Oh man. Man. So what do I do to make that 0 and nil? I'm thinking it's got to be because there's no, it's being set to the 0 value. Or I'm sorry, I'm setting it equal to an empty struct instead of the 0 value, which is probably why it's returning 0, because the empty struct is just the 0 values of all these. So it would be 0, nil, nil, but the actual struct is actually there. It's not nil for the entire struct. So I think that's why it's doing this. And so those are getting set right here. But then if I pass that left, so T1 left, T2 left, if those both get passed in, and if those are both nil, then we should set this answer tree. Oh, it's setting the left equal to 0 and the right. Oh. Okay. So I need to do a check up here if the t dot left is nil and the t dot right is nil. So if t1 dot left equals nil and t2 dot right equals nil, then set answer tree dot left equal to nil. Otherwise, set it equal to the empty struct. Okay. And then the exact same thing for the right. Right. Oops. Left. Right. Right. Okay, so this way, if the current node that we're on are both nil, then we're going to set those equal to nil. Otherwise, set it to an empty 0 value. Okay. Okay, sweet. Well, fingers crossed that it works for all cases. Okay. So what did we get? We got 1, 2, null, 3, 1, null, 2, null, 3. Output was 2, 2, 2, and output should have been 2, 2, 3, null, null, 3. Oh man. Really bad. That is bad. Oh, tree visualizer. Oh, that's pretty sweet. Whoa. It's pretty awesome. I like that. It's cool. So, wrong answer. Output expected. Okay, so I got way wrong here. What is this tree? What does this output tree look like? So 2, 2, 2. So I only made it down to the second level. I have to make it, So I only made it down to the second level. Oh. I think I know why for that, because then that maybe I need to take these out. I was kind of messing around with that, but well, I think I'm going to call it quits for this one. I learned a lot. I'm going to study up on traversing binary trees a little bit more, and then I'm going to come back and try this one again, maybe tomorrow. I just think I'm missing something in my knowledge about how to traverse a binary tree. I'm just not fully understanding the recursion or the exit conditions of those recursions. So I think I'm going to just clear my head of this one for a little bit, study up on binary trees, and then try it tomorrow and see how that goes.